hold your
Thank
applause.
you for coming. Hold your applause.
Well, our talk today is called Decentralized, Not Fragmented, using community agreements to make dApps interoperable. First, we wanted to let everyone know that contrary to what your crypto portfolio tells you, that we are currently in a bull market. Literally, we are in the Beef Palace auction arena of the National Western Stock Show Event Center, so consider yourselves lucky. Oh, thank you. All right, a little bit about us. This is Ken. I'm Brandon. We're both full stack devs. We've worked together across various companies over the past 10 years. Now we're both founding members of Meme, which we'll get into in a minute. But first, here are a few fun facts about us. So Ken is an aggressive typer.
Yeah, I've had two MacBooks where I've broken the enter key on them 3 times. I have a very strong pinky.
An avid ketchup enthusiast.
I do love ketchup also. Yeah. What else did I put on here?
Hobbies.
Oh yeah, I like to 3D print stuff. And I foster a lot of dogs.
He's a good human. Me, on the other hand, I have a degree in design and oil painting, so I have no idea why I'm here. I grew up in a town of 600 people, and I won a trophy for reserve champion feeder steer at the county fair when I was a kid. And if you did not grow up in a town of 600 people, or you've never been to the National Western Stock Show, you probably don't know what that means. Moving on. Now that you know a little bit more about us, let's talk about Meme. So Meme helps people build tools for portable communities. And we define portable communities as groups of people linked by a shared purpose and not the platforms on which they operate. We let you define your community once and then collaborate everywhere. So developers in the room have heard the adage, build once, deploy anywhere, and we feel that same principle should apply to communities. And we do that through what we call community agreements. So technically speaking, Meme agreements are on-chain smart contracts deployed, owned, and controlled by the communities themselves. And within that agreement, you're able to define the roles and the rules for the community that can be extended across any tool or application your community uses. So I don't know if you can see the graphic there, but essentially this community is made up of Alice and Bob, and then within that community agreement, they've defined that Alice is an editor. Editors can approve posts for publishing. Paid members can access posts via IPFS and lit, and then editors share member fees equally. So we feel that tools should bend to the communities and not the other way around. Meme helps communities connect existing tools or build your own tools on top of the community, including tools for collaborative publishing, which we'll get into in a little bit here. And we think those tools should be composable and interoperate according to the community's design. So this is a visual of kind of the stack that we've been building. So at the top, here are some primitives that we've defined that exist across all communities. So communities need to be able to discuss, transact value, create content, and collect content. And then at the bottom, these are sort of the technology primitives that we think allow communities to do those things. So shared state, so the community and its members should be the same across all applications that the community is using. Storage, so a place to store the things the community is creating and collecting. Access to that storage, so making sure that the data is encrypted and only accessible by the members of the community that should have access to that content, and then the roles themselves that define that access. And then that middle piece is where all the biddling is happening right now. So at the very lowest level, the Meme protocol is our open source NFT smart contract layer. And that's kind of where we'll be focusing a majority of the talk today as well. On top of that, we've built an agreement SDK, so any Web 2 or Web 3 savvy developer can come in and start to build applications on top of our stack without having to know Solidity code. And then at the very top level is obviously the application layer. So extensions and dApps built on top of your community. And now here's a little bowl dance party break.
If you look, it's the, maybe you can't see his face, but it's the smile that really gets me. Dancing bowl. All right, so now we're actually going to move into kind of the, get into more of the contract level stuff and really start talking about upgradable smart contracts and then how we're kind of applying those in what we're doing. So just some of the benefits for upgradable smart contracts in general. You get faster iteration cycles, easier to dev. You can actually fix bugs as they're found rather than having to totally redeploy contracts and migrate everyone over. And you can actually share the same implementation across multiple contracts. So you can have one where you're implementing it and then share that logic kind of across a bunch of other proxies, which also reduces size and the overall deployment costs. So you may be familiar with ERC 1167. This is the kind of common pattern used across a lot of upgradable smart contracts right now. The minimal proxy contracts that you can see over here on the left, we've got a user interacting with a contract. So that would be like you're making a contract call through MetaMask, but really what that's doing is it's just forwarding it on to another contract behind the scenes that has all the logic, but all the data gets stored at that proxy contract level. So you can actually imagine multiple proxy contracts all using that same implementation logic. So that again cuts down on deployment costs. There are a few limitations there though, because you only have a single implementation contract and you run into some things like the 24 kilobyte limit on smart contract size. So I actually started hitting this when we were experimenting with putting NFT metadata entirely on chain. And I hit that 24 kilobyte limit. I'm like, well, what the hell do I do now? So I then came across ERC 2535, which is the diamond proxy pattern. So it's the same kind of concept. You have a proxy contract, but then instead of one implementation contract, you can actually have as many as you want behind it. And so that lets you get around that 24 kilobyte limit. You can actually segment your things, segment your logic out into kind of code bundles that have very specific purposes. You can more easily test those things. And so the diamond proxy pattern, this is kind of a visual representation. It was created by Nick Mudge. It recently moved into final status, so it's actually an accepted standard now. So yeah, you can see here each facet would be an implementation contract. So you might have an ownership facet, you might have an ERC 721 facet, you might have an access control facet. And the diamond itself is kind of the sum of all of those things attached onto it. And it gives you a lot of flexibility because you can actually swap those things out. And that's the kind of upgradability part. So this is getting a little even more granular on it. And so the way that it works is that the diamond proxy itself keeps a mapping of function signatures to address of where it's implemented. So if I have a contract that implements, token URI, then I have a mapping in my proxy contract that says when someone calls token URI, I'm going to use delegate call to forward that on to this particular one and then return the result or whatever. And so that gives us lots of flexibility really down to the function level itself. Super powerful. So let's see. Yeah, normally you'd need to fork a contract, make changes, redeploy an entirely different contract. With these, you can actually you can use as many of them, as many functions on each of those implementation pieces as you want, or as few as you want. So you can also imagine this works really well for if you have, let's say, a really well-audited ERC 721 contract, but for your purposes, you really just want to swap out one function. Maybe it's that token URI function. You want to return some slightly different metadata. You could have it so that you are pointing, everything except that one function at the this well-audited ERC-721 contract, and then you could deploy a contract that has a single function that implements token URI and do whatever you want with that. So it gets really powerful and makes things very composable. And so that's going to lead me into EPM, which is a tool that I built that really came out of just us iterating on our contracts and me wanting to more quickly deploy changes and test things. So there's been some great tooling around like hard hat plugins and scripts to like do these upgrades for Diamond contracts. But you know, it's mostly all CLI or like kind of scripts, one-off things. It's not super easy to like grok. So EPM is really a graphical user interface to manage these Diamond contracts in a visual way. So EPM, Ethereum Package Manager, kind of paying homage to like NPM, Node Package Manager. I come from JavaScript, TypeScript, a lot of coding background. So what this tool will let you do is search and deploy or attach any of these facets, alter functions, and you can upload your own and deploy them. It'll also support regular contracts if you just want to upload a regular contract and deploy that. And so what does it look like? So when you come in here to epm.wtf, you can create what I've called a bundle. So you can basically define, like pull in a bunch of facet implementation contracts and then toggle on or off the functions that you want to use and then save it. And so you can see kind of down here, I can't really see. So you can see in here, so like, this is like a base 721 facet that I've got. And so like, maybe I just have a basic thing that handles sale distributions and it sends it to like one single address when you mint an NFT, like if you pay for it. But you can see I've turned it off here, and then actually further up, there's another one that also implements that function, and maybe there you have it sending to like multiple people. You have multiple splits going out to various people. So this is kind of once you've defined that bundle, or maybe you're just using a bundle that someone else has defined, you'd go through and deploy each of those implementation contracts, unless someone else has already deployed it, and then you can leverage what they've already deployed and save yourself on costs. And then once you've selected all those, there's two more transactions. So you'd have to deploy your proxy contract. So you deploy a Diamond proxy contract. And then the second one is doing what's called a Diamond cut, which puts, essentially creates that mapping of what functions are going to what implementation contracts. And then once you've deployed it, you can actually go in and just drop your contract address in or go to the My Contracts part on there, and you can continue to adjust or add facets or turn on or off functions. I've also added the ability to download TypeScript types, like that'll just generate them so that it's easy to pull into your project and do it. There's some example React code that you can see that you can expand, and it'll show you how to kind of quickly just start working with that on the front end. Download the ABI, you know, a lot of that stuff. So this is just kind of showing again, like, you can toggle things on and off, and once you're satisfied that, you know, you've got what you want, just like kind of any upgradable contract, you could, you know, rescind ownership and say, okay, it's good, and now it's locked. Now it's an immutable contract. So just because we start with something that's upgradable doesn't mean that it always has to stay that way. So yeah, and really the goal, I guess, when we're thinking about this holistically from like our meme stack, is that we want people to be able to plug in at any layer, which is why we want to give people easy APIs to work with or an SDK. But we also want people to actually own their community agreements. So when you go and deploy through meme.wtf, you deploy a community agreement in an NFT contract. You are the owner of that contract. You could rescind ownership, of course, if you wanted to. But then you could also take that and go to EPM and totally customize it for whatever your needs are. And with that, we're going to talk about another tool that we have been working on that is kind of a little higher up in the stack.
Yeah, so Symphony is the name of one of the first apps that we're building on top of this stack to allow collaborative publishing. Today, Symphony lets a community use a Discord to decide what to tweet to a shared account. And if you want to try it out, it's live today. You can go to build.meme.wtf/Symphony. We'll be adding more platforms in the future. So for example, you could use Slack as an input to decide what gets published to Farcaster, or Lens, or Paragraph. But for now, you can start to get the idea of how we're trying to break down the barriers of different platforms and make them interoperable. So to sidestep any technical difficulties of a live demo, we've just got some screenshots here, so I'm not sure how well you can see them, but after you onboard your community, create your community smart contract with Meme, you can then enable Symphony. So in this case, we're showing how you can connect your existing community Discord, shared Twitter account that you want to publish to, and then at the bottom there is where you go and start to add rules. And so within a rule, you can define which Discord channels the bot will listen to, or who or what roles can vote to approve content for publication to Twitter. And then you decide on emoji that's used for the votes, along with the number of votes required for approval. There's also a veto step in there, so if you want certain roles to be able to veto certain things so that they don't get blasted out to Twitter regardless of how many people in the community want it to, you can do that. And then we're going to continue to iterate on that publishing process to make it more advanced in the future. So here you can see just an example of a post in Discord that got one unicorn emoji, and Symphony then tweeted that out to our 0xMeme Twitter account, as seen here. So yeah, that's basically the first implementation of one of our apps built on top of Meme. And in the future, we hope to build many, many more apps, and hopefully maybe some of you would be interested in building with us. So with that, we want to thank you for coming out to the Beef Palace auction arena for our talk. If you want to get in touch and learn how to build with us or define what portable communities means, we'd love for you to get in touch. We've got our Twitters and Farcaster handles at the top there, or you can just scan the QR code or go to build.meme.wtf/eth-denver.
Yeah, I would say also if you have any communities that would be interested in using this type of publishing software, definitely come talk to us because we want to get you onboarded, and then we're really looking for kind of pull from the community to decide what the next things are that we're going to enable in terms of inputs and outputs for this. Definitely looking at not just Twitter output, but also longer form publishing, things like that as well. So I think with that, we can open it to any questions if there are any. Yeah, Dino.
Hey, sorry.
We don't know him. No.
Zen boy here. So it sounds like you're open to working with Discord communities that will have a channel where whatever they're posting on the channel will be published to Twitter. That's like one of the functions.
Yeah, that's where we're starting with it. So publishing to Twitter is where we've started with it. But we can imagine there also being multiple steps in there. So maybe it's like it could be more of a curation process, which we've also experimented with, where maybe it's like anyone is reacting in one Discord channel. Once there's enough reactions from the general community, those would go into like a curator's channel where only people with certain roles would then curate it further. And you can imagine there being many steps in that process before it finally gets published out.
Okay, great. And anybody can just contact you guys, and you're going to roll this. Is there a cost to that, or?
No, free. Yeah.
Okay.
Yeah, you can check it out at meme.wtf right now. Cool. Well, thank you everyone for coming out.
Yeah, thanks all.